if you were to kind of plot what you had, so 1, -2, so here's angle A, or point A, and -5, 4 for B, and -5, 2 for C. All right, so if this is what you're looking at, this triangle here, and again, you can't trust the sketch, right? Because it's exactly that. You don't know exactly where this, or what the measures are for this. Okay, and so what you need to do here to find the angle measures is you need to find all 3 side lengths, which you can use distance formula to do that. And then you have a pattern of SSS, so you can use law of cosines to find each of the angles. Okay. So let's say we want to find the distances. Hopefully you have the distance formula still stored in your varlink menu, because all you need to do is type in the coordinates, and that's kind of the point of having that. Yeah. Okay. So in order to access it, you hit this varlink, this second, and then the subtraction key, and then you can scroll down until you get to it. Okay, so once I enter my first one, I'm going to now find AB. And then I'm going to find AC, lastly. Okay, and once I enter each of these, I can now go in and I have the pattern of SSS, which indicates law of cosines, and so I can solve. Okay, now, once again, does it tell me which angle I need to find first? No, it doesn't specifically tell me, and so the best idea would be to find the largest angle. Because the largest law of cosines is always going to give you the correct value. It's not going to have 2 possibilities or 2 possible solutions. So it's always going to give you the exact answer, whether it's an obtuse or acute angle. And so if you start with the angle that could possibly be obtuse, it'll take care of it. You won't have to worry about which angle to find secondly. Okay, so in this case, if you look at this, do you guys know how to work with kind of radicals to see which one is longest? Just put the whole value inside the radical. So if I put this 4 inside the radical, it becomes what? Square root of what is 4? So this is really 16 times 2, right? What would this one be under 1 radical? 36 times 2, and what would this one be inside 1 radical? 4 times 26, right? So that's just putting them all in. Now, from this, can you tell which measure is the longest? Which of these lengths is the longest? A, B, B, C, or C, A? Is there still some confusion? All right, let's talk about some common, like, basic math here. So 16 times 2. Now, when you look at these, you have a 2 here, you have a 2 here. Think about changing this 4 into a 2, right? 4 is 2 times 2. So we could also think of this as 2 times, and let's take the 2 from 4 and move it over here. So what's 2 times 26? Okay, so now, can you tell? So now you just have to compare 52, 36, and 16, right? Okay, so we see that BC is the longest side here. Okay, so let's find the angle opposite that first, because that way if there is an obtuse angle in this triangle, we can find it using law of cosines. Okay, so if we set up law of cosines for this, so here's what we're using. Okay, we're always going to start with our unknown and what's opposite the unknown. So those are going to be the outside pieces. So this is what we're going to start with. Not sure why that's not connecting. If it doesn't come back on, there it goes. All right. So we're going to start with this pair of measures. So we're going to take 2 root 26 squared is equal to the next side squared. So 4 root 2 squared plus 6 root 2 squared minus the product, 2 times the product of those. all times the cosine of our unknown a. Okay, so here is our equation. Right, so all we need to do here, we need to plug this into our calculator, use the solve feature, but remember again, we can't solve for that unknown angle inside here, so we are going to have to use substitution once again. So let's go ahead and say x is going to equal the whole trig ratio cosine of a. So we'll call this x, and we'll change this. We're going to solve for x. All right, the one thing I wanted to do, because I could have changed these into specific single radicals, but I want you to see how you have to enter this on your calculators if you're going to, because a lot of times squaring a number that has a part inside and outside the radical is, you guys get lost in the order of operations on it. So when you enter a number like this, do you see how I have parentheses around the whole radical number, including the part in and out of the radical? You need to make sure that you have those parentheses too. So here's what it'll look like when you enter this. So solve. In parentheses, so its own set of parentheses, I'm going to write this 2 roots 26. So I'm just going to go up and highlight it. And then I'm going to close my parentheses, take it to the power of 2. If I don't do this, if I don't put this grouping symbol around the 2 root 26, the square is only going to apply to the root 26, and I don't want that to happen. Okay? So that's equal to, again, I'm going to take this whole quantity, so grouping symbol, and I'm going to highlight, my next one, 4 root 2. Close the grouping symbol and square that, plus, again, another term that's going to be squared, so a grouping symbol. Highlight 6 root 2, close the grouping symbol and square that whole quantity. Again, be very careful with what you're squaring, otherwise, again, it's only going to square the part inside the radical, not the whole thing. Okay, so now I can subtract 2 times, and then just take the product of those, 4 root 2 times 6 root 2. Again, I don't need grouping symbols here. And then I'm going to multiply that by x. So again, don't forget what x represented. It's times x. And then I'm going to solve for x. And if I've done this right, I'm going to use green diamond to get a decimal answer. What should my decimal value be between? Since it's a sine or cosine ratio, it should be between -1 and 1. And so let's see what happens here. Okay, it winds up being an extremely small number here. Almost the value of, it's essentially a value of 0. Okay, and so when I look at this, if I know that 0 is equal to the cosine of a, okay, you can leave it in this number, but I'll show you here in just a second. Okay, so let's take the inverse cosine of this. We'll highlight that whole value. And we get 90 degrees. So we did a whole lot of work to find out that our angle actually is what it looks like it is, right? It looks like it's 90 degrees. So we actually have a 90-degree angle here. And so what can we do to find the other measures? You can use law of sines, you can use law of cosines again, or because we have a right triangle, remember law of sines and cosines is kind of designated for oblique triangles. What we can do right here is we can just use a trig ratio. So if we think about what we have, I'm just going to rewrite this triangle here. We have 4 root 2. And let's just say I put 2 root 26. Or actually, either one is fine. You can choose any two on here because I can find this angle C by using what trig ratio relates these two pieces with respect to angle C. I have the adjacent side and the hypotenuse. So that is cosine. So I can say that the cosine of C is equal to the ratio of 4 root 2 over 2 root 26. And so C itself is just going to be the inverse cosine of that ratio. Okay, so I'm going to go ahead and just calculate that. So inverse cosine of, and I'm going to put my numerator and denominator in grouping symbols here just to make sure there's no problem with order of operations. So I'm going to highlight 4 root 2, close it off, divide by, in grouping symbols, 2 root 26. And you can just enter it if you want. And then I'm going to close off my entire quantity, for the inverse cosine. I do want my answer to be in decimal, so I'm going to hit the decimal or the green diamond button. And so I get 56.3. And then what way can I solve for my last measure? Just use triangle sum, right? Acute angles in a right triangle are complementary, so I can just take 90 minus this angle, and that's going to give me my last angle, 33.7. Now, I could have also used a trig ratio to find that last angle, and you can, if you have time, you can do it to confirm. With respect to this angle B, with regard to B, I have an opposite side in the hypotenuse, so which trig ratio relates that? Sine. So I could have said that sine of B is equal to 4 root 2 over 2 root 26, meaning that B is equal to the inverse sine of that ratio. And so I can come up here, and I'm just going to take this value here because I already have the information. And I'm going to change this from inverse cosine to inverse sine. And if I've done this right, it should be 33.7 to confirm my answer, and it is.